In this video, we'll create a data pipeline that fetches data from a REST API and loads it into a MySQL database, all using Python and SQL. Let's begin. This is the system architecture for our project. And the data source here is a football API. And I found this on a website called RapidAPI. So that's a platform that hosts over 35,000 APIs across different categories like sports, finance, weather, and so on. So we want to get the data from this API and then load it into our destination, which is MySQL. And we're going to use Python and SQL to help us with this. Now, before we begin, we need to ask ourselves two questions. Number one, what's the problem? And number two, what does success look like? So, a sports bar in London is popular for hosting English football games, especially the Premier League. So, the main screen shows the games, and the rooms are packed with football fans. But once the game is over, everybody wants to check where their teams rank. So that actually causes a few problems. So first of all, the Wi-Fi gets overloaded. So everyone starts pulling out their phones and starts searching for the Premier League table on Google after each game. That floods the bar's Wi-Fi and then it starts to become slower for everyone else. And staff are forced to context switch. There's now a growing number of customers that ask staff for the league table once they notice the Wi-Fi is down. So that forces the bartenders to stop what they're doing, check the results on their phones and laptops, and then answer each customer again and again. So all this context switching ends up slowing the bar service itself. And the atmosphere and vibes dips. So when a match ends, the big screen often switches to ads, then the energy in the room drops, and everyone's focus moves away from football, or some customers end up leaving the bar early. So what we need to do is we need to flip the script here. Instead of all this chaos, we want the fans to automatically see the live standings at full time. So let's have a second screen next to the main big one. That shows the updated Premier League table. And we can also have small tabletop screens and tablets around the bar. And that's going to have the same info. And the standings are going to be refreshed automatically after full time. So that way, everyone sees the same screen with the latest results without having to bother staff anymore. But why does this project even matter? One thing you have to remember is companies have databases and websites that hold useful information to the general public. So that can be sports data, finance data, marketing data, and so on. But some people use bots and web scrapers to collect the data directly from the websites. Now, that can put too much load on the website and break it. And this ends up hurting the experience of the company's actual target audience. So, what these companies do is they actually provide APIs so that developers can directly access it. So, instead of scrappy HTML, you can actually get clean, structured data in JSON format. And this is not just for public data, right? So, inside companies as well, one team might build an API so another team can use the data, and vendors as well. So vendors also build REST APIs for customers so that they can programmatically fetch the data they're paying for. And they do that without exposing the actual database. So some of the skills that companies are looking for are people who can pull data from a REST API, clean it with Python, and store it in a relational database. Right. Of course, it's not an exhaustive list of data skills that are needed or programming skills that are needed, but it's a good start. And I'm already hearing some of you say, yeah, but AI can do that already. Yes, but that's only because someone else built it first. So somebody else built the pipeline first. You need to remember, right? AI cannot handle this entire pipeline from start to finish, especially in places that process large volumes of data. So there will be times where you're working with billions of rows, and AI tools are not ready to handle that kind of workload reliably. This is one of many situations where humans are preferred over AI, full stop. And only people who can build these pipelines safely will be trusted with these type of tasks in the real world. So let's move on to the stages of this project. And I've classed them into three basic ones, okay? So we're actually going to be using an ETL pattern here, right? So of course, the first step will be extract, which is fetching data directly from the API. The next step will be transform, which is passing the response into a data frame. Okay, so the API will actually return JSON, and we're going to now pass this JSON response into a Pandas data frame. Now, the third step will be load, and that's loading the clean data into MySQL. We're going to create a database, a table, and we're going to make sure that the data that's inside there resembles what's on the actual Premier League website. Right, let's start designing our solution. So we need to ask ourselves three key questions here. Number one, what information do the fans want to see? Number two, what data do we need to generate that information? And number three, what does good data quality look like and how do we check it? So first of all, what information do the fans want to see? So at the end of each football game, the fans just want to know one thing. Where is my team on the league table right now? So they may ask, are we on top of the table? Are we slipping down to seventh place? Or are we at risk of relegation? And different people have different reasons why they care, right? So some of them will have placed bets and they want to see if they've won or lost in that moment. Others may just be anxious about whether their rivals are catching up to them or overtaking them. And you're going to get some that are just casual fans. So they just want to stay updated in real time. But the goal is to give each of them a clear live snapshot of the table standings, right? Without needing to open Google to search and slow down the Wi-Fi in the process. Okay, so in simple words, a table showing all 20 Premier League teams and their rankings. Number two, what data do we need to generate that information? So the English Premier League has 20 teams participating across the whole of England, the UK. And the table standings, that's going to include things like each team's name, where they're positioned. Okay, so that's after full time. How many games they played up till date, how many games they've won, drawn, and lost, and so on. You're also going to need things like number of goals scored, how many conceded, the goal difference, points, and how their form is. The table we create has to replicate this. Number three, what does good data quality look like for this? And how do we check? So there are expectations for the table itself. What do we want this table to look like? What data quality rules do we want in place? Number one, there must be 20 teams. So that sounds obvious, but we need to make sure that there are no blank cells in any of the team names. Number two, all cells must be populated. So there is no cell in this table that's allowed to be empty. And number three, numeric fields must be integers. So an integer is a whole number, okay? So when you're talking about things like position and rank, that has to be a whole number. You can't be 1.5 on a table. And if you're talking about how many matches played, you can't play 36.275 matches. It has to be a whole number. So that would be the position, the rank, the matches played, games won, drawn, lost, number of goals scored, the conceded goals, all of that has to be integers. Okay. Now, these data quality checks are important, but I want to keep this video focused. So we're going to cover this more in depth in another video in the future. But what we need to focus on is what the table itself looks like. And what I want to do now is I actually want to open up Excel. Right now, I have a blank Excel workbook open. And what I want to do is I want to create a mock-up of what this table would look like once we start building it. Okay, so I'm just going to zoom in a little bit. So let's start adding columns into this. So the first column will be rank. So what position the team stands in. And then we have the team name. We have matches played. We'll say W for wins, D for draw, L for losses, and then we'll say GF for goals for, GA for goals against, GF for goal, oops, GD for goal difference. And then we'll have points, and then we'll say form, and that's just the last 5 matches played. Okay, so let me just zoom out a little bit. So let's just say number 1, for example, and we want to make this as realistic as we can. So let's say United. Please comment section. I don't want no funny comments. So we'll say 35 wins, 2 draws, say 1 loss, say 104 for goals for, goals against. We can say, make it 21. The goal difference will be goals for minus goals against. And the points, so the points will basically be the number of wins times 3. So for those of you that are not aware, in the Premier League, if a team wins a match, they earn 3 points. So assuming this team, Manchester United, have played 35 games with a win, 35 times 3 is going to be 105. But we also need to add the draws. So if you draw a game, in fact, I probably should wrap this in brackets. There, just plus that. So this is the total number of points. So if you draw a game, you just earn 1 point. So because they've drawn 2 games, you just add 2 to the final results. And we'll say 4 wins and 1 draw. Second place will be Crystal Palace. So let's say 38. And then you get the point. Let's say, so who's getting relegated? Yeah, sounds realistic. Okay. Or something like that. But you get the point. So if I was to just, let me just rank these with borders. This is an idea of what the table is going to look like. Okay, so you have your rank, you've got the team name, matches played, the wins, draws, losses, goals for, goals against, goal difference, points, and their form, right? Okay, so this is a mock-up of our Premier League table. So I'm just going to type in mock-up, or I'll name this mock-up. The next question is, what are the steps in making this possible? I would actually open up a new sheet and I'll call this pseudocode. So pseudocode simply means the steps in an algorithm or the steps in developing something. I'll just type in steps and then if you guys remember the high level steps. So remember, number 1 was extract. That's fetch data from API. Then number 2 was transform, which was to pass the API response into a data frame. And then the third one was load. And that's simply upload clean data into MySQL database. So these are the high level steps. But what we need to do now is we need to be more granular. We want to be more specific on each step that's involved in our high level steps. So I'm going to, perhaps I should actually open up a new sheet. So I'm going to call this, let's say high level. And open up, I'll just copy this. Then I'll call this low level. Okay, low level meaning more detailed. There's more information involved. Okay, so I'll do steps, call this low level. And it's important that you do things like this because you want to be clear on your approach. Every single step you take has to be clear, right? And clarity does come with action, yes. But if you put things on paper down, then you're able to actually look at each step and say, okay, can I justify this step being there? Can I justify this one being there? And then you start eliminating steps, you start introducing more steps, okay? So I'll show you how I normally do it. So I've said extract, that's fetch data from API. So what does that actually mean? What does that involve? We can say things like, read doc to understand API. That's one step. Create GitHub repo and clone locally. That's another step. create.env file. That's to protect our secrets. Create main.py file. Create.gitignore. And what else can we do? Load libraries into main.py. Add API keys into .env. If I can spell. So yeah, I'm doing this on the go. This is exactly what I do, right? I'm just brainstorming the steps I'll take in building this. Okay. So create API request. Then I guess you send the API request, and then yeah, let's write that. Send get request. So it's going to be a get request. Okay, well, those are all the steps I can think of. The next part is to transform the data. So pass response into data frame. So yeah, pass JSON, I'll say API response, and it's going to be in JSON, into a Pandas data frame. I could be more specific. I can preview the data frame once I've done that. And then once I've done that, I load data into MySQL. So I'm going to need to connect to the database. I suppose I need to connect to MySQL server first, just to test if the connection is even legit. I also need to load MySQL credentials into variables and then set up the connection. Also need to upsert into MySQL table. So I'll talk about what an upsert is later in this video. Then I need to check if upserts worked. So check if load was successful, I'll say. And then I'll say upsert into Premier League table, because we know we're uploading into MySQL. Okay, I think that's pretty much it. All right, so what's first on the list? So read docs to understand API. Okay, so let's open up RapidAPI. I'm just going to drag this here. Okay, so Rapid API. Then I am going to go to the official website, and then I'm just going to scroll. Actually, let's go to API Hub. Then my API football's here, so I click on that. So this is our main page. This is a code snippet of a request you can send to the API. And if you look at target, this is set to Python because I like Python. This is my API key, by the way. I recommend you not exposing your API key. When you extract this and then you enter your IDE, make sure you load it into a .env file so that you protect it from malicious users. But for this video, I don't mind exposing mine because I'm going to delete it anyways. And on the left, you're going to see different endpoints we have access to. So I'm interested in the stand-ins, and you can do it by league ID and team ID. I think league ID will make more sense for our example. So I'm just going to click that. And once again, you're going to see a code snippet of what you can paste into your IDE. But we're not going to need that. I'm going to open up the docs. So I'll click on external docs. And by the way, for those of you that don't actually understand what a documentation is for, a documentation is just a file or page that tells you how to use a tool. So it's normally written by the developers who built the tool. So in this case, the football API. And as a rule of thumb, a good documentation should be up to date and it should be easy to scan, but you don't actually need to read the whole doc. But it is recommended so that you're using the tool the way it was intended to be used. You're going to see things like update frequency, that's going to be important. How many calls you're recommended to make a day. You don't want to make too many API calls. Otherwise, you're actually going to be a nuisance to the service itself, and you don't want the developers behind this to now deny you access to it. Okay, but anyways, there are mechanisms in place that prevent you from even making more calls than you should, so you don't even need to worry about that. And if you look at this, there's even a tutorial on how to actually make this work. So if you want to look at all that, that's completely up to you. But things like this is actually what's important. So the query parameters, as you can see, you have the league, you've got the season, you've got the team, and the season is required. So you actually need to specify which season you're dealing with. And you also have the header parameters. Okay, so the API key is compulsory. You can't actually make an API call without one. So you're going to need to make sure that's included in your request. And you have the different responses. So 200, if you get 200 once you make an API call, that's good. If you get 204, that means it worked, but there's actually nothing in the response. If you get 499, that means the request is timed out. And if you get 500, then there's an internal server error. So something's wrong on their side. But anyways, let's get back into the main page. Under the app tab, you've got the API key there. You've got the request URL. If you go to parameters, you've got the league ID, you have the season, and it's optional, but you can put the ID of the team as well. And under the header, you have the host, so the RapidAPI host. So each of these is going to be useful. When you're building the actual request itself, you're going to need all of these, and you're going to have to combine them together and structure it in such a way that the API understands what you're talking about. But what we need to do is we need to create a GitHub repository. So I'm going to open up GitHub, and then I am going to go to plus sign here, and then I'm going to click on new repository. I'm going to name this Premier League standings 2020 to 2025, let's say. Then the visibility is public, so everybody can see it. And then I'm going to create the repository. Awesome. So I'm actually going to open up Git bash, right? So I'm going to click on that. So I'm going to actually clone this locally, okay? So I'm going to type in, and by the way, you don't need to understand what I'm doing, but what I'm basically going to tell it to do is to navigate into a directory of my choice, and then clone the GitHub repository, and then open up VS Code. I'll show you what I mean. So CD, and then users, dev, documents, GitHub, demo. So what folders do I have inside there? Okay, so perhaps I can clone it right here. Cool. Okay, let's clone it inside this location. So I'm going to copy this link and then go back to git bash. And then I'm going to type in git clone. And then I'm going to paste the link right here. And then I'm going to hit enter. And then I'm going to type in ls. And then I'm going to use cd. Then I'm going to type in Premier League standings 2020 to 2025. And now I'm officially in. So what I'm going to do is I'm going to type in code, and that's going to open up VS Code for me. Awesome. What I'm going to do is I'm actually going to open up Anaconda this time. I want to open up VS Code through Anaconda. The reason why I want to do this is because I've got a virtual environment that I'm already working with. Okay, then let me enter GitHub, then demo, and then, okay, so Premier League standings 2020 to 2025. And then I'm going to do conda activate. And then I'm going to say Python tutorials, virtual environment. And now I'm inside my virtual environment. So if I just type in code, it's now going to open up VS Code underneath this virtual environment. So I'm just going to drag this repository into VS Code. And now we're officially in. So what I want to do is I want to create a few files. So if you guys remember, if I just open up Excel, in fact, I could probably just tick these off as well. So I've read the docs, let's just say. I've created a GitHub repository and I've cloned it locally. So now I need to create a .env file, a main.py file, and a gitignore file. So let me just go back into here. So the first file I'm going to create is a .env file. And then I'm going to create a main.py file. And then I'm going to create a gitignore file. And in fact, what I'm going to do is I'm actually going to create a notebook, right? I'm going to call it, let's call it test for now. I'll come up with a better name at some point. So this is a Jupyter notebook, and I'll just make it clear. This is for testing purposes. Okay, so we'll call this, let's just call this Premier League standings for single season. So the .env file is for writing our sensitive credentials like API keys and database details. So when you're talking about the host, the port, the user, and the password, the .env file is where all of that information goes to. The .gitignore file is actually where you want to hide other files and directories from public view. So when we commit our repository to the remote branch, we don't want to expose certain files to the rest of the public. Any files you don't want to expose to the rest of the public, add to your gitignore file. We'll also create an assets folder, okay? So if we have any interesting screenshots or any other assets we want to save there, then that's just for our audit trail. So let's start working inside our notebook. So we want to add a few libraries into this, okay? So we will start with the OS library. We can also start with the JSON library. So the OS library, the JSON library. We also need the request library as well. We're also going to need the Pandas library. And going to need MySQL, and we're going to need .env. Okay, so I'm going to hit enter. Let's see if all that works. Awesome. Okay, I suppose it's worth walking you through why we need each library as well. So the OS library, that's just for talking to our operating system. So my laptop is a Windows laptop, and I'll be able to just read and write information about different files and all that type of stuff. The JSON library, so the API response is going to be in JSON format. That's going to help us handle all that. The request library, so this is actually what allows us to send requests to the API. The Pandas library lets us work in Pandas. So when we're talking about data transformation inside tables or data frames in this case, the Pandas library is one of the best out there. Now, from MySQL, this is going to allow us to connect to MySQL programmatically. So instead of us just doing everything manually inside MySQL Workbench, we can also do it through Python. So we can actually load data from Python via the MySQL library. And .env file, that allows us to just load secrets from our .env file safely. Okay, and that's actually a good starting point. So we want to load our environment variables. And to do that, we need to call the load.env method or function. So let's start adding the sensitive credentials into the .env file. I suppose a good starting point would be API key. Let me see if I can actually make this larger a bit. Then the API host. So this is all for RapidAPI. API football. Let's find those details. So remember, you can actually pick it from here, or you can also pick it from here because it's already been defined for you. So I'm just going to copy here because I can't be bothered. and I just paste it here, then go back to that. And then the API host, same thing. Then just paste it there. Also need MySQL credentials. So I'm going to say MySQL host. We also need port. We also need the database name. We need the user. And we need the password. So let me just put this at the bottom. I do this for readability, so I like indenting things. Okay, now we need to open up MySQL Workbench. So I'm just going to find that quickly. Make sure you have MySQL Workbench installed if you want to follow along. So you can click on this icon right here, and you can find some of these details here. So I'm just going to go back into VS Code, and then I'll just type in some of them. So the host is, in this case, the host is actually going to be local host. Port be 3306. The username will be root. And then the password, let's just say, we'll just say strong password. And the database will be Premier League database. Right. Let me just space them out a bit. Now, if you can see on my left, you're going to see that all of these files are actually green. And that's because Git is currently tracking the changes inside each file. But the problem is, if we commit this, then there's a chance that everyone can see our sensitive credentials, and we don't want that. So we need to go into git ignore and then type in .env into it. And what that's going to do is this now suddenly turns gray. And that means Git is no longer tracking the changes inside this folder. And on top of that, once we commit this entire repository into our remote branch, this is no longer going to be part of it. So our sensitive credentials are safe. Now, the next thing we need to do is we need to load our environment variables. So that's another name for it, environment variables, into our session. So I first need to actually open up a new cell and then define our variables once again here. So I think I'll start with the API key, and we are going to use the OS library, and we're going to use get-env, and we're going to reference the API key inside our .env file. So if I was to hit enter, and if I was to, let's even print what's inside the API key. If I tried printing what's inside here, it's going to say none. And that's because, it's not because there's nothing inside the .env file. It's because I haven't actually given it the permission to load my sensitive credentials into this session. And to do that, I need to actually run this cell right here. So I'm going to hit enter for that. And then I'm going to try this again. And now you can see my API key is now showing. And that means it has the permission to load the environment variables into this session. I'll type in API host. So I'll just follow the same approach for each variable. I'm also going to specify the season that we want to work with. So in our case, it's going to be 2024. This is the variable for the season we want to extract. So keep in mind, this is actually the year when the season starts. So for example, if you want to see the Premier League standings for the 2022-2023 season, we would actually add 2022 because that's the year the season started. Okay, so I'm going to do 2024 for now. And the league ID is going to be 39. And if you check the site itself, you're going to see league is 39. So that's for the Premier League. Now it's time to set up the API request. So I'm going to enter a new cell and I'm going to type in the URL. So the URL, that's something we can get from the official website. So we can actually grab it right here. Then we need headers. So once again, we can do the same thing. If we're feeling like saving effort. But instead of leaving the API key exposed, I'm going to replace this with our variable instead. And for the host, I'm going to do the same thing. And that way, in the future, if our API key changes, we don't have to manually change the header itself or the headers itself. All we need to do is just update the API key, and this ends up changing as well dynamically. And that follows the dry principle, so don't repeat yourself. So specify it inside a file once, and your variables pick it up. Now, the final thing we need to do is to also set up our query string. And this is going to be the league ID. So if I just type in league ID, and it's also going to be the season we want. Right. So if I hit enter, the API host is not defined. What could be the problem? Ah, I didn't actually. Okay, let me hit enter here. So I need to run this cell. And then I need to run this cell again. Okay, that's fine. So let me just confirm that the API host. Okay, good. So it now recognizes that. Let me just confirm the season has been registered. And I'm guessing the league ID too has been registered. Let's try that again. Awesome. Okay. And if you want, you can even do the query string. Good. Okay, so that's worked. So now we can extract the data from the API. And that means we need to set up the request we want to send to it. Okay, so think about it like sending a message on WhatsApp to someone asking for something. So in this case, we want to ask the API to send us the Premier League standings for the season that we've specified. Okay, so we want to ask for the Premier League table standings for the 2024 and 2025 seasons. But we need to structure it in a way it understands. And that's going to be through a GET request. So a GET request tells the API we want to get data from it, right? Okay, and we're going to use the request library for this. Now let's structure our request. So we're going to type in response, and then we're going to use the request library to get data. The first parameter is going to be the URL. Okay, I'll just make that explicit. The second parameter in this is going to be the headers. So we'll just add in headers. And the third one's going to be params. That's going to be our query string. So this is going to be our GET request. The moment we execute this, we've officially sent a request to the API. So the first argument needs the URL. The second argument, that's going to need the headers. And the third argument is going to be for the parameters. I've named the variable query string. So I'm just going to hit enter. Good. So what I need to now do is load the response to another variable. Okay, and that's going to be in JSON. If I hit enter, because I've now run this code, what I expect the API to send us is a block of data in JSON format. And this is actually going to turn it into a Python dictionary. So I'm going to show you what this looks like, in fact. So this is the JSON that's been sent to us. So by default, as you can see, all of this is just squashed together and it's quite hard to read everything. It's quite big actually. So what I want to do now is I actually want to format this in a structure that's easy for us to read. So we need this in a friendlier format. So I'm going to name this formatted payload, or maybe formatted response. There, we use JSON, and we're going to use the dumped function. The first argument is going to be our payload, okay? So I'm just going to type in payload. And the second argument is going to be the indent. And that just means how spaced out we want it. So one would be having the values close to each other, and five would be having them spaced out from each other. So I'm going to use 4. So I think 4 is a good balance. So if I just hit enter. So remember, this is before I'm formatting our response. Because can you see? Can you see how squashed everything is together? And now I'm just going to print what this now looks like. So as you can see, it's much more friendlier. each of the values within the keys are now spaced out. And there's now a healthy amount of space between the keys and the values, which makes it easier for us to read. Now, the next stage will be to pass the data we need from the payload. Okay, we don't need everything the API has given us. We just want to drill down into just the league table where the teams are ranked. But some of the fields that we want are hiding inside the JSON, right? So we actually need to drill through this step by step. Think of this, right, as you navigating through different folders and directories on your computer. Okay, there's just so many things that you're trying to scan through, but we don't want everything here. We're only looking for a specific thing here. So remember, JSON and dictionaries are made up of keys and values, right? So the keys are on the left and the values are on the right or inside the key. If you look at what the payload looks like, right, you're going to see that there's a few top level keys here. So you have get, you've got parameters, errors, results, paging, and then you have response. The only key we care about is the response. And why is that? And that's because the values we want are hiding inside the response key. So all of this is what we want, and that's hiding in the response key. We don't care about any of the information going on here for now. I'm going to enter a cell below this and type payload. And I want, let me just scroll up again. So we have response. Okay, so I want payload, I want response. Okay, so what does that look like? As you can see, the response key holds a nested list of JSON data where the fields are locked inside of. So the response key holds a list of nested JSON data where all the fields we want are locked inside of. So now we need to go a level lower. This is a list because the data, the nested JSON is inside squared brackets. If I scroll all the way to the bottom, you're likely going to see a squared bracket that closes this. If you want to see what the first item looks like, just type squared brackets and then type 0. And there we go. So now this is the first element inside the list. Counting in Python starts from 0, not 1. So we're telling Python right now to return the first object in the list. But if we ask for the second item in the list, it's going to break. So if I just type in 1, as you can see, it says index error, list index out of range. And that's because this list only has one item in it. So you can also say that using 0 in this case actually is unwrapping the list to convert it into a dictionary. So I'm just going to do that again. Now inside this JSON, we want the league. So I'm now going to open up square brackets again and then type in league. And inside the league, you have keys like ID, name, country, logo, flag, season, and standings. So standings is what we want next. So let's do standings. So now that we've entered the standings key, we can now see something interesting happen. We have a list inside a list. So it's not obvious why we have this, but it's a design choice that's made by the developers. And sometimes adding more layers can support more use cases later down the line, but that's not within the scope of this video. So what we want to do is we simply just want to unwrap the outer list, right? Okay, so we want to unwrap this list here. So I'm going to type in 0. So let's execute that. So we're now left with the inner list, and this should list all the teams with their rankings for the 2024 season. And I think it's actually best for us to name this the standings list. So let's call it that. Okay, so let's see what that looks like once again. Okay, so once again, if you want to make this readable, let me just enter a cell below that. Let's call this formatted standings list. We use JSON dumps. First argument is standings list. The second argument would be the indentation. Okay, so if I say print, and this time, what I'm going to do is I'm just going to use a few line breaks. And then I use formatted standings list. So let's see what that looks like. Aha, there we go. So it's formatted better now. Anyways, that's just for if we want to debug or we want to have a look at any more useful values inside our list. It's time for us to now create a data frame. What we want to do now is want to turn this JSON into a clean table. And the first thing we're going to do is we're going to create an empty list and we're going to call this rows. So this is going to hold one row of data for each item. And then next, we're going to define column names. Okay, so we're going to need a season, we're going to need position, we'll need team ID, team, names played, points, and form. So this is going to be useful once we create the data frame. So I'm just going to hit enter. In fact, we'll go back into that. So what we're going to do now is we're going to need to loop through every single team in the standings list. Okay, so I think it's best for me to break down what the process will look like. So the standing list, remember the standing list right here, this is a list of dictionaries. Each dictionary is one team's record. So for example, this is Liverpool IC, and this is going to be Liverpool's details for the season we're in. We need to create variables that represent each value inside this record. So for example, if we want Liverpool's points, we're going to create a variable called points and then read the value inside the points key inside this dictionary. Okay, so let me see if I'll see if I can make this a bit more understandable. So I'm just going to open up a temporary variable. Let's call this points, or let's call this Liverpool points. Then the standings list. Okay, and because it's a list, okay, so let's do that. And then the points. This is the points. Okay, so cool. So let's just type in points. Okay, so if we want Liverpool's points, this is basically what we want to do. So that's 84 points, okay? So we would need to do this for each team, okay? So we're going to type for, let's say, club in standings list. So the first one's going to be season, okay? And season is going to be 2024, okay? So that's going to be the same for every single club. Then position, that's going to equal the club. And I think inside, okay, this is called rank inside the dictionary. So we're going to call this rank. And then the team ID, club, and that's called, okay, so it's inside the team key, and then inside there is an ID for it. Okay, so what we need to do is we need to be clever. So we'll type in team, then type in ID, then we'll type team. That's going to equal club. I'm guessing it's going to be team and name, something like that. Yeah, that's it. That's the name one right there. Okay, cool. Okay, what's next? So we have played. So we're just going one by one through each one. So that's going to be okay. Okay, played is here, so that's underneath the all key. Okay, so we have to enter all first. That's the first step. Then after that, we go to played. So yeah, it's quite a long process, but once you've set it up, then you don't need to set it up again. So this is just initial setup efforts. The alternative is tougher. That means you have to do this for every single club. And that's not going to be convenient. So all win, I believe. Yep. And now let me type in active row. Because remember, we're appending the rows into the data frame. Now I want the first one to be season, next one position, team ID, team played, one, draw, lost. It's 4 goes against difference, points, and form. So this is actually a tuple, okay? So what we're doing is we're taking all of this and we're packing them inside a tuple, okay? So a tuple is a row of data and you can't make any changes to this row once it becomes a tuple. So I'll probably just name this, let's name this tuple of club record. And then we're going to append this tuple into the empty rows variable that we created earlier. So that tuple is going to be appended to this list. So let me just do that. Tuple club records. So this loop repeats this entire process until all 20 teams are completed. So I'm going to hit enter. Okay, let's have a look at that. Goal diff. Okay, let me have a look at the it's goals diff. Okay, so let me even copy that. I'll just copy that and then just paste it there. But it's really just an S, so I can just add the S as well. It's not big, not a big task. Hit enter. And there we go. So if I want to have a look at the rows, let me just type print rows. So that's Liverpool. Let me get the mouse. So that's Liverpool. This is Arsenal. So let's scroll. Manchester City. Okay, let's go all the way to the end. Let's see if all 20 teams have been done. Okay, 2024 20th. That's Southampton. Okay, so that's team number 20. So that looks legit. Awesome. Okay. So it looked like it worked. Let me just space this out because for the sake of readability. Okay. Awesome. So remember, if we didn't actually have this loop in place, what we have to do is we have to actually manually write this process for all 20 teams. And that's a lot of time wasted. And also, if the API changes or one day the league itself changes, then the process will break. So it's good practice to use for loops in situations like this. But yeah, now we can create the Pandas data frame. So that's awesome. Type in data frame, PD data frame. So we're going to use the data frame class from the Pandas library. And the first argument is going to be the rows. And the second argument is going to be the columns. And we'll just have column names there. So I'm just going to hit enter. Let's see if that worked. So we're going to use data frame head. Okay, let's change this to 20 now. Okay, awesome. So it looks like all the teams are there. And if you want to see the data types, you can also, let me just enter a new cell, data frame or df.info. And you can see the data types for each of these. So the season is an integer, position's integer, teams played or matches played, the wins, the draws, the losses. Okay, so a lot of this is integer. That's looking good. The final step is to load this data into MySQL. So what we need to do is we first need to connect MySQL to Python. So let's first start by reading our credentials from the .env file. So if you remember, we have the MySQL credentials for our database here. And I'm going to go back into our file and then I'm going to type in MySQL host, and then I'm going to use os.get env and I'm going to type in MySQL host. Let's just confirm that works. Okay, that's looking good because if I go into there, that's what I've got there. So that worked. Okay, so let's complete the rest. So I'm just going to copy this and then just change this to port, change this to user, then this to password, and then this one to database. Okay, so let's hit enter. We want to connect to the server first and not the database because if you connect to a database that doesn't exist, then the connection is going to fail immediately. So I'm going to just open up a new cell, and then I'm going to type in this server con, we'll call it server con. And we're going to use the connector from MySQL. And we're going to use connect. So the host is going to be MySQL host. The port is going to be MySQL port. The user is going to be MySQL user. Password is going to be MySQL password. Also, I'm going to add connection timeout. Okay. Now, the reason why I'm adding a connection timeout is because we want to tell the process to stop after 10 seconds, stop the process so that it doesn't run without doing anything. So if it comes to a problem and it's not able to carry this out, then terminate all operations immediately after 10 seconds. I'm going to use auto commit and I'm going to set that to false. Right. So if we set this to false, this is going to mean that we only commit a transaction when we call the commit operation. Okay, so that means we're writing to the database safely. And we can add raise on warnings, and we can set that to true. And that what that's going to do is it's going to turn MySQL warnings or errors into Python exceptions. Okay, so I'm just going to hit enter. Okay, so I got an error on this, and I think I know the reason why. I need to create a user inside MySQL. So let's actually jump into MySQL Workbench, okay? And we're going to set up all of the relevant things that will make this work. So let's create a user, okay? So let's create user if not exists. And I'm going to call this Premier League app writer. That's called host. That's our host. I think I need to wrap this in single quotes. And let's say identified by strong password. I think that's the password we used. Let me just check that. But I believe that's the password we used. Yes. Okay, good. Okay, so let's execute this. So we now have a user and we should be able to use this instead. So we use this. Maybe worth granting a few privileges too. So I'll grant it access to select tables, insert data, date, let's say delete, drop tables. Actually, we'll say create. Alter maybe. Okay, we'll say drop. And we're going to name our database Premier League database. And this is for any table within this database. And we're granting this privilege or these privileges to this user. Let me just add semicolons. Before we run this, actually, we do need to create the database because at the moment we don't have a database and we don't have tables. So if I go into schema or schemas, you can see that these are the only databases we have. We've just given it a new user. So I want to confirm if all of this works. Okay, so let me run this again. And then I'm going to run new. Okay, I think that's all good. So now let's create the database itself. So I'm going to type in create database, if not exists. Then I'm going to name this Premier League database. Then hit enter. That worked. I'm going to create the table itself. So remember, the table has to match what we have inside the data frame. Create table, if not exists, stand-ins. Okay, and the first column is going to be season. That's going to be an integer. And we don't want any nulls inside this column. Then we'll have position. And we also want that as an integer. And we don't want any nulls here either. If you remember in the beginning, in the data quality rules, we don't want any cell to be blank. And then team ID, we want that as an int. And we don't want that to be null either. And then this is going to be team actually. This is going to be varchar. We want it to be 100 characters max. Okay, so varchar is another name for string, and the maximum amount of characters allowed for a team name is 100. And no, we don't want any blanks inside our team name. And then played is next. Let me just confirm. I just scroll up. So season, position, team ID, team, and we have played. Yeah, okay. And then we have one draw, lost, goals for, goals against, goal diff. Okay, cool. Let's go back into that. Played. That's going to be an int. That's going to be not null. And then one. That's going to be int. It's null. Okay. We'll copy the rest. Like that. Draw. Lost. Goals for. Goals against. This is goal difference. Then points. Points. Final one's going to be form, but it's going to be varchar as well. In fact, let's just type it. Form. Varchar. The maximum amount of characters is going to be 5 because with form, you want to find out the result of the last 5 games for each team. And that's going to be represented as letters. So 5 characters should be fine. Now we want a primary key for this. So I'm going to type in primary key. And the primary key is going to be made up of the season and the team ID. Okay, once again, it's just for this project. Okay. In the real world, you're probably going to come up with something more sensible. And we're going to make sure that each team has a unique position on this table. Okay, so no two teams can have the same position, right? And how do we do that? We type in unique key. I'm going to call this unique season position. And we're going to use season and position. So this ensures that no two teams have the exact same position. Then we should close that with a closed bracket and a semicolon. Zoom out of this for a split second. Let's just get rid of that. Okay, so if we were to run all of this, let's have a look. So no database selected. Okay, so what I also need to do is I need to type in use Premier League database. Okay, so I need to run this. And this tells it that I'm using the Premier League database. Okay, and then once I've done that, I can now run this. And it should work, as you can see right there. Awesome. So if I was to go back into VS Code, scroll all the way back to the bottom, I need to confirm that the server connection works as well, by the way. So let me create a server cursor. I need to create a cursor for this. And I need server connection to help me out here. Okay. But let me just confirm it works. So I'm going to print if the server connection is successful. Connected to MySQL server. Okay. Awesome. Okay. So we've managed to connect to MySQL using Python. That's going to be useful. Okay. And we've connected to the server. Awesome. So we need to close that because we are done. Okay, so just type in close. And then we also need to close the connection here. Now we need to connect to the database. Okay. So at this point, we're pretty sure that the database exists. So we'll just connect to it. So I'm going to call this DB connection. I use connector. I use connect. It's pretty much similar credentials to all of this. So I suppose I can just copy this. And then I need to add the database. So we need to create a cursor for this database connection. Okay, so I'm just typing cur, C-U-R for cursor, then DB connection. Okay, so let's print to see if this is actually successful. Connection to database is successful, let's say. Okay, what's the problem here? Access denied. Ah, okay. We need to grant it privileges. So let's go back to MySQL Workbench. We need to actually run that query. So we need to now grant it permission to actually access the database. At the moment, we haven't done that. So once we run this grant command, then it should have access to every single table within this database. Okay, and it's going to be allowed to select, insert data, update data, delete data, create data, alter the data, slash edit, and drop tables. So let's run this. Okay, so let's try this again. Fingers crossed it works. And there we have it. And now we need to check if our table actually exists. So we already know it exists, but let's confirm that programmatically. In other words, let's confirm that using Python. So I'm going to type in cursor executes, and I'm going to type in show table, or like show tables actually, like, and I'm going to type in a percentage sign and then S. Okay, so this is just a placeholder for our value. Okay, it'll make sense in a moment. Then I'm going to use fstring, and actually, it may be worth doing. Let me specify the table name here, standing. So that's the name of our MySQL table. And then I'll just call that. Okay, and I also need to do a comma. By adding the comma there, I'm telling Python that this is a tuple. Otherwise, it's going to look at that as a string, and once it executes that, it's actually not going to work. And also, you could open your code to different types of risk. It just tells Python it's a tuple, okay, not a string. But before I run that, I actually want to add an if statement. So if whatever you fetch is empty or equal to none, I want you to actually raise a system exit, okay? So we're giving it permission to stop this process if it doesn't find anything in the results, okay? Now, what message do I want it to tell me? So let me just add my table. So this table is not, let me just put that in caps, not found. Please create it. This table. And if it is found, then print this table exists. Given, put the success indicator in the beginning. Continue to the next phase. Okay, so let's run this to see if this works. Awesome, it exists. Okay, let's change the name. Let's call it stand-in, not a real table. Let's see if that works. Aha, so it doesn't work. In fact, let's wrap that with single quotes, just for clarity. So if I run that again, or if I call this, let's call it another name, football NBA. Let's just call it. This table, football NBA, is not found. Please create it. Okay, so that works. Awesome. So if I type in stand-ins again. So this confirms that Python is actually looking into our database and searching for that specific table. And it's managed to find it, so that's good. Anyways, now that our database exists, the final step is to load the clean data into SQL. So, but we don't want to just insert data, right? We want to handle updates as well. So in case we run the script later in the season, and that's what you call an upsert. So an upsert is a combination of the words update and insert. So in other words, if the row does not exist in the table, insert it. If the row already exists in the table, then update that row with the new values. That's all an upsert is. Let's begin. So let's start the upsert operation. So the first thing I'm going to do is I'm going to define the table columns. That's going to be quite similar to what I had before, actually. So let me just see if I can just grab all this. This is going to allow us to map the data frame columns to what's inside the standings table in MySQL consistently. Otherwise, we're going to start seeing column mismatches. So the values for points may go into the team name instead. So we don't want things like that to happen. And then let me create a standings data frame. And this time the data frame is going to take the table calls. You can enter that. So let me just have a look and see what that looks like. Okay, looks fine at the moment. But what we need to do now is we need to extract the rows as tuples from the data frame. So let's type in standings, records, tuple, or tuples. So we're going to use the standings data frame and we're going to use iter tuples. Okay, and the index is going to be false. The name is going to be none. And then we need to materialize this into a list. Okay, so that means we're converting the iterator into a list of tuples. So list of standing records, standings records. And this is simple. We're just wrapping this into a list. Okay. So now we can write our Upsert SQL query. So oops, let's try that again. So f strings. Okay, and then we're going to start with the insert into statement. And then we're going to call our SQL table. Then we're going to define our columns once again. So season, position, team ID, team, played, won, draw, lost, 4, goals against, goal difference, points, and 4. Let me just confirm in MySQL. That's what it looks like. So if I just type in select star from standings, season, position, team ID. Okay, yep, we're on track. That's good. Now I type in values and then I'm going to actually add placeholders. So the percentage sign followed by an S. And this is going to be for each column we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so this needs to be done 13 times. 3, 6, 12, then one more. Also, let me not forget, we're going to name this as SRC. So this is an alias we're giving this row. So this is the incoming row that's going to be uploaded into the table, right? So think of it as the name for each row we add to the table. And then this is where the upsert takes place. So we're going to type on duplicate key update. So on duplicate key update. So this simply means if the exact row already exists in our table, then do not insert a new row. Instead, just update the existing one. That's what we're saying right here. So we'll start with position. So SRC position, then got team. We're skipping team ID because that's always going to remain the same no matter what. So the team may change their name, maybe. You never know. The matches played, that's subject to change, of course. Games won. Yep. Draw. Lost. Scores 4. It's against. Difference. wins. And finally, form. And then we close the upsert statement with that. So let me just space each of these out. All right, so let's hit enter. Awesome. And we also want to find out how many rows were uploaded as well. So let's create a variable for that. Loaded to MySQL. That's going to be the length. List of standing records tuple. Yep. I'm going to hit enter for that. And then we want to try and execute now. So I'm going to use a try and except block. So exception, that's E. This time I'm going to use cursor execute many. And the first argument for this is going to be the Upsert SQL. Second argument is going to be our list of standing records tuple. Then DB connection. We're going to commit this. So if this works, I want you to give me a success message. Upsert, say attempted for number of records, rows. If this didn't work, I want you to actually roll back and I want you to print rolled back to this. And let's add the finally block as well. We want to close this connection. We want to close the cursor and we also want to close the connection itself. Database connections now closed. Cleanup completed. Let's just say. And I want this on a new line. So I type that. Let's do 2 new lines. Okay. But let me walk you through what this is about, basically. Okay, so inside the try block, we have the execute many method. Okay, and the first argument is the Upsert SQL that we created, and the second is going to be the list of standing records in tuple format. So it's going to run the same Upsert SQL query multiple times. So that's going to be one for each tuple in our data. And this is going to commit this whole process. If it works, it's going to give us a success message. Now, in the except block, what we have is the rollback operation. Okay, so this is going to reverse any changes if anything fails. So if something goes wrong, cancel everything. And the finally block is our cleanup step. So it's going to close the cursor, it's going to close the database connection, and it's going to print a message confirming it's done all that. So let's give it a run. Let's see if it works. And there we go. It looks like it works. So let's check if the load was successful ourselves. So I'm going to go into MySQL. So if you remember, I ran this earlier and there's nothing inside it. So if I run this again, as you can see, we have all this information here. But let me just open up a new canvas. So I'm going to let me just expand this a bit. So do select star from standings, and we're going to order by, let's say, position. Okay, let's see what that looks like. Okay, so this is our results. Now, let's actually do this. We're going to do a side-by-side comparison, right? So I'm going to open up our data again, and I'm going to type in Premier League Table 2024-2025. So this is the table. This is from the official Premier League website. Then I'm going to select you. Okay, let's try that again. Right, let's just close this. In fact, let me just Get rid of that. So, according to the official website, or according to Google, Liverpool came first. And according to our data set, Liverpool comes first. How many points did they finish off with? 84 points. So this states they have 84 points. So who is, let's say, 7th position? Nottingham Forest. So this is Nottingham Forest. And that seems to be correct. They finished on 65 points. Our data says the same thing. So that looks good. Let's look at Tottenham. Okay. Tottenham finished 17th position according to our data set. What does the official one say? It also says they finished 17th in the Premier League for the 2024-25 season. Okay, that looks right. And the teams that were relegated to the lower divisions were Leicester City, Ipswich Town, and Southampton. As you can see, the bottom three on our data set is Leicester, Ipswich, and Southampton. So that looks good, guys. And that's basically how you fetch data from an API and load it into MySQL using Python and SQL. I hope you've enjoyed this data project. If you want to see more projects like this, subscribe to the YouTube channel. Stay blessed.